We've learned that some substituents activate a ring or deactivate a ring, and now we're going to take a look at some of the effects that cause this. And these include inductive effects and resonance effects. So we're going to start by looking at the inductive effects. In an inductive effect, the biggest thing to kind of keep in mind, these are effects happening through sigma bonds. And inductive effects are things you think about kind of in terms of electronegativity. So when you have an atom that's more electronegative than carbon, it's going to pull electron density through that sigma bond. So in our first example here, we have fluorine bonded to the ring. We know fluorine is a very electronegative atom, and if you draw a dipole arrow, you're going to draw it toward the fluorine. Fluorine will be delta minus, and that will pull electrons towards itself, putting positive character onto the ring. So we would consider this inductively electron withdrawing. In our next case, we have this carbonyl bonded to the ring. A couple of ways you can think about this. One is just in terms of the dipole here. So that gives the oxygen partial negative charge, the carbon partial positive charge. Well, if that carbon is partially positive charged, it wants electrons. So where does it get electrons from? It pulls them out of the ring. So again, this is inductively withdrawing. Another way to think about this is by drawing the other resonance structure. So in this resonance structure, now you can see that there's positive character on that carbon that's pulling electrons inductively out of the ring. So this is just thinking about electrons being pulled through this sigma bond. Our final example has a methyl group bonded to the ring. So with this, you need to think back a little bit into organic 1, and remember talking about hybridization. And we can have an sp hybridized carbon, sp2, and sp3. Here we have more s character. And remember that s orbitals are closer to the nucleus. And that nucleus is positively charged because it has the protons. So for that reason, electrons are pulled and held more tightly in the sp orbitals. So effectively, an sp hybridized carbon is more electronegative. An sp3 hybridized carbon is less electronegative. So if you're going to draw a dipole, the dipole arrow will always be going in this direction. So now if we come back to this ring and take a look, we have an sp3 hybridized methyl, an sp2 hybridized carbon in the ring. Our dipole arrow is pointing into the ring, so that's inductive donation.